Good evening, ladies and gentlemen. My topic today for my next discussion on my channel is integral calculus. We are now through with differential calculus. So let's proceed with integral calculus. Integral calculus is actually the reverse of differential calculus. So let us say if you can recall your differential calculus while we are discussing integral calculus. I will check my camera. Oh, it's fine. Let us start. Integral calculus. Before we could proceed with integral calculus, we must know what's the definition of integral calculus. The simplest definition of integral calculus is something like this. Integration is the process of finding the function or equation when the derivative or differential of that function or equation is given. That's integration. The process of finding the equation when the derivative or differential of that given equation is given. That's integration. Integral calculus. Okay, I will bring out the symbol for integral calculus. The symbol for integral calculus is something like this. It is something like a distorted capital letter S. Okay, that's the sign for integral. And the sign for differential or derivative, they are synonymous, okay? The sign for differential is just simply small letter d. Okay? So while we are taking integral calculus, we should familiarize ourselves with the sign. The distorted big letter S is the integral sign, and the small letter t is differential or derivative. But the term that's most prevalent used in integral calculus is differential. Okay, differential or derivative, they are synonymous. Okay, so small letter d is differential. Okay, before we could integrate some functions in integral calculus, like it's just the same in differential calculus. If you do not know the formula on how to take the differential, in integral, it's the same. If you do not know the formula on how to take the integral of a certain function, you don't know integral calculus. So I must have to bring out, okay, I will try to bring out the first four equations being used in integral calculus. For the meantime, take it easy. We'll do it gradually, so we will absorb it better. Yeah? Okay. Number one, general properties of indefinite integrals. Why indefinite? Indefinite because if we try to bring out our answer, there's always a plus c. Okay, plus c, a plus constant, meaning c is a constant, and since that c is not specified for the meantime, it refers to be indefinite. Okay? But if this constant c is given a value like a plus 2 or minus 2, we term that definite integral. But for the meantime, we'll just do first the indefinite integral by just placing a plus c to our final answer. Okay? I will try to bring out formula number one. Formula number one. The integral of the differential of b equal to b plus c. That's formula number one. I will try to bring out the derivation of this, why the integral of the differential of any given function is just equal to that function plus c. Why plus c? It is indefinite integral. We are not given the value of plus c for the meantime, so it refers to indefinite integral. That's number one. The integral of the differential of any given function b is equal to b, that function b, plus c. I will try to bring out the derivation of that. Why this formula came out. I will check my camera. Okay. Number two, the integral of the sum of several functions. Like the differential of so many functions, under integral it's the same. The integral of the differential of so many functions, like the differential of b plus differential of w plus that differential of z is equal to simply b plus w plus that plus z plus capital letter C. It's indefinite integral. Meaning, the sum of several derivatives or differential is just the given functions b plus w plus that plus z plus capital letter C. I will try to bring out the derivation of this. So you believe in me. Okay, number three. The integral of a constant times the differential of any function b, okay, is equal to c. We bring out the c, the small c, times the integral of the differential of b. And if we try to integrate this one, it will be equal to c. What's the integral of differential of b? You go back to equation number one. It is b, right? It is b. So c times b is cb. This is plus capital letter C. In short, the integral of c differential of b is equal to c, the integral of dv, and this is equal to small letter c times that function b plus c. I will try to bring out the derivation of that. So memorize the three by heart. I will proceed first with number 4 because our discussion for tonight is up to number 4. The integral of b to the n dv, okay, is equal to b raised to n plus 1 all over n plus 1 plus capital letter C. Okay? It seems it is under the power formula. The integral of the differential of b to the n dv is equal to b raised to n plus 1 all over n plus 1 plus c. This b here is just the variable thing we use for the meantime. It could be u, it could be z, it could be x. This is a general equation, okay? This b here could take any representation. It could be x, it could be y, it could be z. Okay? Meaning, the integral of b to the n dv equal to b raised to n plus 1 over n plus 1 plus capital letter C. It's indefinite integral. The value of C for the meantime is not given. Okay, I will check my camera again. Okay, I will try to bring out the derivation. To bring out the proof of this, that the integral of the differential of any given function is just the given function plus c. Okay, I will try to bring out the derivation of that one. We let y for the meantime equal to small letter b plus capital letter C. Okay? Take the differential of both sides. Differential or derivative. We are not differentiating with respect to any variable. Just take the differential. Okay? The differential of y is equal to the differential of the quantity on the right hand side or the derivative of b plus c. Derivative or differential is the same. Okay? The derivative of y is equal to the derivative of the given quantity on the right hand side. It is b plus c. Taking the derivative now. The differential or derivative of y is just dy. Okay? On the right hand side, it is a sum of two terms. First function, second function. First function is b, second function is a pure constant. So if we try to take the derivative of this or differential, treat them separately. Okay? Use your knowledge of differential calculus. So differential y now is equal to the differential of b is just dv, and the differential of c is 0. The derivative of any constant, okay, is 0. So see this 0. This is 0 now. Right? The function on the right is b plus c. The derivative of b is just dv. The derivative of c is 0 or just simply dv. Okay? Therefore, dy now is equal to dv. Take the integral of both sides. Okay, we are now integrating. Okay? That's why our topic is integral calculus. The integral of differential of y is equal to the integral of differential b. We rearrange. We put this integral of dv on the left hand side. The integral of differential of b, okay, this one will be on the right, equal to the integral of the differential of y. Okay, this is an important thing. If this integral and differential go near each other, okay, I will now say they will cancel out. Okay? The integral of the differential, it will cancel out. So what will come out on the right hand side will just simply y. Just like on the sine and the arc sine. The sine of the arc sine of any given function is just the given function. Okay? That's why the integral of the differential of any given function is just the given function. The integral of the differential of y, okay, will be y. That's why I told you the integral of the differential, it will cancel out. Okay? So the right hand side will be y. But what is y? Y is b plus c. Meaning, our formula number 1, the integral of the differential of any function b, if we try to integrate this, and the formula for this is just simply b plus c. And that is actually formula number 1. You got it? There's no magic. We are differentiating and integrating at the same time. That's why before we study integral calculus, we should know differential calculus. Some part of the solution is differential calculus, in some part is integral, some part is algebra. So to pass integral calculus, you should know differential calculus, algebra, trigonometry, plus integral calculus. Because our topic for the meantime is integral calculus. Okay? Kaya I will repeat it before I will proceed. The integral of the differential of any given function b is equal to that given function b plus c. That's formula number 1. Memorize that by heart. Okay? Number 2. Number 2 is the integral of the sum of several differentials. It's the same in differential calculus. We let y for the meantime equal to function b plus w plus plus z plus capital letter Z. Okay? Take the differential of both sides. The differential of y equal to the differential of the right hand side. What you will do on the left, do it on the right. Okay? The differential of y is just dy, and the differential of the sum of the function on the right hand side, it should be equal to the sum of their differentials. Take the derivative or differential separately, as you see it. So dy now, the differential of b is just dv, the differential of w is just dw, plus plus the differential of z is differential of z plus what's the differential of pure constancy? It's constant, so this should be 0. Okay, so this is 0 now. This is gone. The differential or derivative of any constant is 0. Okay, simplifying this one now, dy now is equal to dv plus dw plus plus dz. Okay, take the integral of both sides. Okay, take the integral. What you will do on the left, do it on the right. The integral of the differential of y equal to the integral of the sum of these differentials, or just simply equal to the sum of the differentials individually. It's easy. Okay, then we rearrange, so we put this on the left, therefore the integral of dv plus dw plus plus dz equal to, we place this on the right, equal to the integral of dy. But if this integral go near this differential, they will cancel out. Right? And what will come out on the right will just simply y. But what is y? Y is this. Right? Therefore, in general now, the integral of the differential of sum of several functions is equal to y. But what is y? Y is equal to b plus w plus plus z plus capital letter C. So in general now, the integral of dv, dw plus dz is equal to b plus w plus plus z plus capital letter C. And that is actually formula number 2. This one. It's this. No magic, right? Okay, let's proceed with number 3. For number 3, we let y equal to small letter c times b plus capital letter C. Take the differential of both sides. The differential of y equal to the differential of the quantity cb plus capital letter C. Then take the differential or derivative of the right hand side individually. Therefore, the differential of y is just dy. First one is constant times the function. It's the same under the differential. The derivative of a constant times the function is constant times the derivative of that function. We bring out the constant first, okay, times the differential or derivative of the given function, plus the differential or derivative of c is 0. So this is 0. Or this is gone. No more. Therefore, dy now is equal to c dv. dy now is equal to c dv. Take the integral of both sides. The integral of differential of y equal to the integral of c differential b. We rearrange, we put this on the left. The integral of c dv equal to the integral of differential y. This one. We put this on the right. As I told you before in integral calculus, when this integral sign goes next this differential sign, they will try to cancel out each other. Okay? So the integral of the differential of y is just y. But what is y? Y is small letter c times b plus capital letter C. So in general now, formula number 3 under integration, the integral of any constant times the differential of that given function is equal to c times that function plus capital letter C. And that's actually formula number 3. We just reverse this situation because in differential calculus, we are given y as a function of t, and then they are asking for the differential. But in integral, we are given the differential, and they are asking for the function. It's just the reverse. That's why without knowing differential calculus, you will not pass integral calculus. Let's proceed with number 4. Number 4 is the so-called power formula. If under differential calculus, there is a power formula, under integral, there is also a power formula. I will check my camera. Okay? Let's try to bring out formula number 4. Okay? We let y equal to b raised to n plus 1, this is n plus 1 all over n plus 1 plus capital letter C. We let that one to be equal to that for the meantime. Okay? Take the differential of both sides. The differential of y is just dy. The differential of the right hand side is the differential of b raised to n plus 1 over n plus 1 plus c. But the terms on the right hand side, a little bit complicated. The first one got a fraction and the second one is a pure constant. So take the differential or derivative individually. Okay? The differential of y, this falls under the power formula. But n plus 1 is a constant. Actually, we could bring it out. Okay? 1 over n plus 1 times the differential of b